Video notes 12.2. Got some calculating to do, and you'll find out that it's equilibrium but better. Okay, just gonna give a shout out to Thomas right now. Thomas, this is it, your shout out. Woo! Keep rocking. Make sure you guys look at these book connections in chapter 16. You'll find lots of this information. Self-check 16.3 and 16.7 you should do after you do the video notes. Okay, so guess what? Water is in equilibrium with itself. What? Water is a mixture of water, H plus, and OH minus. Because if two water molecules collide, okay, you will get an H3O plus and an OH minus. And you might be saying to yourself, Self, you told me it was H plus, but these two things mean the same thing. Because a hydrogen ion can be transferred from one water molecule to the other, and you get these two things. But because it's going to take two waters to collide to get this, then for every two waters that collide, you get one of these and one of those. And so water is neutral because the amount of H plus and the amount of OH minus are equal. Keep that in mind. So to get to understand acids and bases, there's some calculations you can do that talk about or that help you decide how much H plus and OH minus are in a solution, and that decides whether it's acid or base. Okay, so in order to get the pH of a solution, take the negative log of the hydrogen ion concentration. So these are, you better get to know these really well. If you want, so the P does is it takes the power of the hydrogen ion to base 10 so that you can make a concentration number, which is small, into a number between 1 and 14. Okay, so if you take the negative log of whatever, you get the P of whatever. All right, so you can get a pH, you can get a POH. But what if you know the hydrogen concentration, or you want the hydrogen concentration? Then you can use the pH to get it. The hydroxide concentration is related to the POH. And then pH plus POH equals 14. And that's 14. Then the hydrogen ion and the hydroxide ion together, concentration multiplied together, gives you 1 times 10 to the negative 14th. So H3O and H3O plus mean the same thing. And so if you see them, just interplace them with each other, replace them with each other. Okay, so the pH scale tells us how acidy our acid is and how basey our base is, because acids and bases depend on how much H plus and OH minus are present. Okay, if there's lots of H plus, the pH scale is 0 to 7. If there's lots of H plus, if there's equal H plus and OH minus, pH scale is 7. The pH is 7, and if there's more hydroxide and less hydrogen, you're talking basic solutions. All right, so where does the H plus and the OH come from? Well, if something's a strong acid, we already know that it means the concentration of the acid is the concentration of the hydrogen, because strong acids 100% dissociate or ionize. So if you know the concentration of the acid, you know the concentration of the H plus. So you can automatically figure out pH. So what is the pH of a 0.00356 molar HCl solution? Well, this is an acid. It's a strong acid. So that means the concentration of HCl is equal to the concentration of H plus, because all of the HCl turns into H plus. So if we want the pH, all we have to do is hit negative log, plug in 0.00356, and you get 2.45. Okay, so is this solution an acid, a base, or neutral? Well, the pH is less than 7, so it's an acid. Woohoo! All right, let's try another one. This time it's base. Strong base means that the total concentration of the base is the total concentration of hydroxide, because all of the base 100% ionizes, dissociates completely, so it all turns into hydroxide. All right. So what is the pH of 2.45 times 10 to the negative third molar NaOH? Well, this is an acid or a base. It's a base, and it's strong, so that means the concentration of a strong base is equal to the concentration of hydroxide ion. Okay, so if I negative log 2.45 times 10 to the negative third, I get 4.71. But wait, if I negative log hydroxide, I'm getting POH. If you negative log OH, you're getting a POH. And then pH plus POH is always going to equal 14. So the pH is going to be equal to 14 minus 4.71. So the pH of this solution is Uh-oh. Maybe I did this wrong. Oh, the pH is, oh goodness. I better redo this one. Negative log. Uh-oh. See, this is why it takes so long. So, negative log of 2.45 second E negative 3 is 2.61. I lied to you. It's 2.61. So then the pH is going to be equal to 14 minus 2.61. The pH equals 11.39. Okay, which makes sense. This is a base, so the pH should be basic. Basic. All right. Now, that works as long as you know you have a strong acid or a strong base. So, if we are given, what if we want to find pH? Well, then we look at this and we say, okay, this is an acid, so it's a strong acid, so the concentration of the acid equals the concentration of the H+. So H+ is 0.15 molar, so the pH is negative log of 0.15, so the pH is going to be 0.82, and that is an acid. All right, what about this? Hey, in this one we don't know what acid produced this, but we know it gave us the H+ concentration. So right away you can negative log it. Negative log of 2.5 times 10 to the negative fourth gives us 3.6. So is this an acid or base? It's an acid because the pH is less than 7. All right, now what if we're given other information? If we're given the concentration of hydroxide, sodium hydroxide, to be 1.5 times 10, we have to say, is this an acid or base? It's a base. Strong or weak? Strong. It's one of our strong bases. So that means the concentration of the base equals the concentration of hydroxide. So the concentration of hydroxide is 1.5 times 10 to the negative third molar, because that's what bases do, break up totally. Strong bases break up totally. So then we need the pOH is going to be negative log of 1.51 times 10 to the negative third. Right? So the pOH is 2.82. All right. Now, if it's 2.82 for the pOH, then it doesn't ask us, but the pH of this would be 11.18. So this is a base on the pH scale. Okay, well, it's a base no matter what, but the pH scale tells us that it's over 7. Okay, if I want the pOH of this, and I know the OH, I just negative log it, 0.001, and I find out pOH equals 3. Now, how do I decide if this is an acid, base, or neutral? Well, it's easier to work with pH, so pH equals 14 minus 3, and I find out it's 11, so it's a base. Okay, these are both bases because one has pH 11.8, the other one has pH of 11. So we want to find pH, knowing we want to find, oh, who did this wrong? I did. Okay, give the pH, find the pH given this, but these are really pHs, so pOH equals 14 minus 2, pOH equals 12. pOH equals 14 minus 11, pOH equals 3. Okay, but give the pH given the following pOH, right? Acid or base? Well, this tells us acid, and this tells us base. All right, now that I got that all done. Okay, we want the hydroxide concentration given the pH. Well, here's the pH that relates to hydrogen. So if we want to find the hydrogen concentration, you take 10 to the negative 3.22. All right, so 10 to the negative 3.22 gives us 10, and on your calculator you have to hit the caret, negative 3.22. That gives us H plus equals 6.03 times 10 to the negative fourth molar. But we want OH minus. So there's an equation we can use that says that H plus times OH minus is always going to equal 1 times 10 to the negative 14. That's the KW for water. That's water's equilibrium constant. So then we would just say that the OH is going to be equal to 1 times 10 to the negative 14th divided by 6.03 times 10 to the negative fourth. And you get 1 E negative 14. I'm plugging it in right now. You can hear the calculator. 6.03 negative 4. And you get 1.66 times 10 to the negative 11th molar for hydroxide. Okay, and that is the concentration of hydroxide. Now I want H plus given POH. I'm going to do this one a little different than the one I did above. POH equals 2.15, pH equals 14 minus 2.15. Okay, and we find out that pH is 11.85. So now that I know pH, I can get H plus, because H plus is going to be equal to 10 to the negative 11.85, and so the the H plus is going to be 1.4 times 10 to the negative 12 molar. Okay, so you just have to be able to use those equations I gave you earlier. Alright, so if you're given H plus and you want OH minus, one step, all you got to say is 1 times 10 to the negative 14th divided by 6.33 times 10 to the negative 4th. So you can use that KW equation, and if you do that, you find out that you get 1.58 times 10 to the negative 11th molar hydroxide concentration. All right, if you want the H plus concentration, you have to take the KW expression and divide it by the concentration of hydroxide, and you get 5.13 times 10 to the negative 14th molar. Okay, so I'm backing up to this, and I want you to write these formulas down, okay, and then you have to be able to use them. I'll explain them more in class. Okay, so that works all the time for strong because you know directly your H plus and your OH minus. But what if the acid or base is weak? Then we have equilibrium. So what is the pH of a 0.24 molar acetic acid solution? Well, let's write the equation for it. Acetic acid is HC2H3O2, okay, and at equilibrium with its ions. Now, the fact that it is weak means that the this side is going to have more present at equilibrium than that side. So that Ka is going to be an expression that tells us, a mathematical way to tell us that this is going to be, if we write the Ka, we're going to find out that H plus times, so this is an equilibrium expression, but guess what we're calling it? We're calling it Ka. Why? Because it's for acid at equilibrium. Okay, and I know from a chart that I'm going to give you that the Ka for this acid is 1.8 times 10 to the negative 5th. So that means it's always products over reactants, and this is a small number, that means the reactants, there's more of a reactants. Okay, so if I want to solve this, I have to ice it. Okay, I'm going to ice it up here. I is initially, I have 0.42 molar of acetic acid, and then H plus is going to be 0, and C2H3O2 minus is going to be 0. But then that's going to change. Some of that's going to go away, and you're going to get some of that and some of that. So at equilibrium, we're going to have 0.42 minus X, 0 plus X, 0 plus X. All right? So if I want to find the pH, I need H plus. So I would go ahead and plug in X times X is 0.42 minus X, and that has to equal 1.8 times 10 to the negative 5th. Alright, so this goes to X squared over 0.42 minus X equals 1.8 times 10 to the negative 5th. And that's where our algebra kicks in. So you can plug this into the calculator equation solver, or you could solve, if we're solving for X, we get X squared plus 1.8 times 10 to the negative 5th X minus 7.56 times 10 to the negative 10th. I think that's a 10. Nope, that's a 6. Negative 6 equals 0. Solve the quadratic formula, A, B, C. And when you're done with that, you find out that X equals 2.739 times 10 to the negative 3rd. Okay, and that's molar, but that X represents the H plus. So now pH equals negative log of 2.7, I'm going to round it to 7.4 times 10 to the negative 3rd. So the pH of this solution is 2.56. It's a lot of work to figure out pH, but pH comes from H+. H+ comes from the equilibrium dissociation of the HA. Right? But not all of it dissociates, only a small number does. And this is a small number, 2.74 times 10 to the negative third. All right? So that's how you solve it if it's weak. So there are tables that you can look up to talk about the acid ionization constants. So if it has a very large ionization constant, which side is favored? Well, that means the products. It's always products over reactants. So in this one, products are favored, so the very large number on top means it's ionized completely. So this is a strong acid. All right. And so is this. Sulfuric acid is also a strong acid. And then if the Ka's are less than 1, right, that means that there's more reactants than products. So you'll get a Ka table. What about bases? Same thing for bases, except it's the base dissociation. Right? So let's practice with a base. Calculate the pH of 0.35 molar N2H4. So you're saying to yourself, Self, what is that? It's not an acid, doesn't start with H. So it must be a base. But it's not a strong base because it doesn't have OH minus from group 1 or 2. So we need to write a dissolving equation for this. So we're going to put N2H4. And we're going to put aqueous. And that's going to react with water in equilibrium. Bases are H plus takers, N2H5 plus. So we got an extra H and a plus on that. And water turns into OH minus. So this is a base because it produces OH minus, and it's an H plus taker. So the Kb expression is going to be N2H5 plus, so products, OH minus, over reactants. H2O is a liquid, so we don't put it in, N2H4. Okay. The Kb, let's go back. The Kb for hydrazine is 1.7 times 10 to the negative 6. 1.7 times 10 to the negative 6. All right, so what are we trying to find here? We're trying to find pH. pH comes from H+. But guess what we have in here? OH minus. All right? But pH plus POH equals 14. So we can do a lot of things, but we can't get H+ out of this. We can only get OH minus out of this. But you solve it the same way. We're going to have x squared. Let's ice it. I'll go back and ice it for you. So at initially, we have 0.35 molar of this, 0 this, 0 that. It's going to change. Some of that's going to dissociate, and so we're going to get some of that and some of that. And then at equilibrium, I know this is hard to see, but you can write it better in your notes, 3.5, and this is going to be x and x. So then x squared is going to be equal to the equilibrium, x squared, x goes in there and there, and that's going to be equal 1.7 times 10 to the negative 6. And so that means that you can solve this, set it equal to 0, put it in a graph solver, or you can write out the equation. So x squared plus 1.7 times 10 to the negative 6x minus 5.95 times 10 to the negative 7th is equal to 0, and then use the quadratic formula and solve A, B, and C. After you do that, you'll find out x equals, where is my x equals 7.693 times 10 to the negative 4th. Practice the math on that. But what does x represent? X represents hydroxide. So that's a hydroxide concentration. This question wants pH. So if I negative log the hydroxide, 7.693 times 10 to the negative 4th, I get a POH. And then the POH is going to be equal to 3.11. But what does this question ask for? This question asks for H+. pH. pH is going to be equal to 14 minus 3.11. So the pH of this solution is 10.89. Okay, so it's a base. And we found out the hydroxide concentration. Lots of stuff to do. To review, you can. This diagram, you can draw it if you want, but it shows the connection between all of the formulas. Okay. Calculators rock. You can use equation solver instead of quadratic if you want. Indicators are colorful and uses the Le Chatelier's principle. I actually left that over from the last one. What do you use pH for? Swimming pools, blood poisoning, soil suitability, antacids, acid rain, all of those all determine or use pH to help explain. Okay. Please read chapter 16 I know this is long, but you can do this self-check now. All right? Peace out, and just another shout-out for Thomas since I forgot forever. Remember, Thomas, Boxing Hippo loves you. Peace out.